Total resistance of a circuit. So how do we find that for series? Get ready to get blown away.
I know it.
What do you do?
I know the equation.
What is it?
Resistance or equivalent resistance equals resistance 1 plus resistance 2 plus...
Gosh, it's like you looked right off the practice.
No, actually, I knew that.
So how do you find the resistance? You add them up.
Oh, I just put the equation. Is that
Yeah.
available?
Yeah, so the equivalent resistance is R1 plus R2 plus... Yeah, you literally add them up. So 3 resistors are connected in series. R1 is 1, R2 is 2, R3 is 3. What's connected to a 3-volt battery? Find the resistance and the current. So the resistance is this. Equivalent resistance equals 1 plus 2 plus 3 equals 6. Sarah likes this problem. She's a fan. No, yeah, I can see you like this one. 6 ohms. Just remember the funky horseshoe. That's the unit for resistance. Funky horseshoe. The Colts logo. The Colts logo is resistance. Although this year they didn't offer much resistance this year, so it was a...
They the Chiefs, though. They were in the Super Bowl.
How did the Chiefs one game they lose this year against the Colts?
Yeah, that is true. They just took an off day.
An off day?
Yeah. The whole team was like, you know what? Let's not worry about today.
No, I do appreciate
It's fine.
how they won against the Bengals.
So V equals IR is how we find equivalent current. So we need to find the current of the circuit. So current is I. So the voltage is 3 volts. Current is I. Resistance is R, which we just found to be 6. So divide both sides by 6. And we get I equals 1/2. I'm going to leave things in fractions a lot this unit. So just kind of get used to that. If you want to write 0.5 as your answer, that's totally fine. But I'm going to do a lot of fractions this unit. So just prepare yourself mentally, emotionally, spiritually. Yeah, spiritually. Sometimes you need a little help from the Lord for fractions.
I was thinking about crystals. When I hear spiritually, I always think about crystals, just because like people really believe in this stuff. But yes, the Lord. We need to cook.
All right. Any questions on 3? Okay. We're on notes 2. I gave them to you last time. Do you need one?
No, I got it.
You got it? Okay. Sam's just late to the party.
Sam just got here.
All right. How do you find equivalent resistance for parallel circuits? So parallel circuits are different. Remember, the reason we add the series circuits is because you did that lab 2 where you found that as you added light bulbs, the current went down for series, which meant the resistance had to go up. When you did that same lab, you found that for parallel, the current went down, the current went up, which means the resistance has to go down. So how can I add things and they get smaller? Here's how you add them to get them smaller. You do 1 over everything. You add the inverses. So it's 1 over REQ equals 1 over R1 plus 1 over R2 plus whatever else there is. So you add the inverses. Yep. It's all right. I was singing Love Roller Coaster earlier for a problem we were doing in Physics 1. But no one knows that song. It's terrific, though. All right. 3 resistors are connected in parallel, R1, R2, R3, to a 3-volt battery. Find the equivalent resistance and the current of the circuit. So equivalent resistance is 1 over REQ. So it's 1 over 1 plus 1 over 2 plus 1 over 3. Now, you can turn these into decimals. 1 plus 0.5 plus 0.33. However, that's not going to be as accurate, and it might make your numbers a little nasty. So I like to leave them as fractions. Now, some of you got done with algebra class or whatever class, and you're like, I am never using fractions again in my life. Okay? Far be it from me to make you break a lifelong promise and oath to yourself. You can do these in decimals if you prefer. It's a little trickier, but you can do them that way if you want. I'm going to leave them in fractions, and I need to get common denominators. So the common denominator between 1, 2, 3 is 6. Good. So I would multiply by 2 over 2 to get 6. I would multiply by 3 over 3 to get 6. And I multiply by 6 over 6 to get 6. So this gives me 6 over 6 plus 3 over 6 plus 2 over 6. And that gives me 11 sixths. And you're saying to yourself, Mr. B, you said fractions were going to be better. This is not better. 11 sixths is not better. I don't like 11 sixths. It's a nasty... Here's why it's better. Well, yes. But 2, this is not the answer. 11 sixths is not the answer. That's 1 over r. I don't want 1 over r. I want r. I have to flip this to get r over 1 instead of 1 over r. If this is a decimal, you have to take 1 divided by the decimal value, and you're going to get something nasty. If you leave it as a fraction, all you have to do is flip the fraction. So this becomes REQ equals 6 over 11. So all you had to, yes, exactly. So all you have to do is flip it. That makes it so much easier than having to do it on your calculator. All you do is just flip the top and the bottom, you're done. So that's the equivalent resistance. So now you got to do the current. So V equals IR. The voltage is 3. The current is I. The resistance is 6/11. And again, you're saying to yourself, Mr. B, now we're doing 6/11 to the other side. That's just gross. Remember, to get a fraction to the other side, you multiply by the inverse. So it multiply by 11/6 to both sides. And again, this is starting to look like it's going to be gross, but have faith in me. Not a lot, but a little. 3 and 6 cancel, and it becomes I equals 11 over 2. And that's not so bad. So the 6 is in the denominator, the 3 is in the numerator, so I canceled the 3 with the 6 and had a 2 left over.
Or it could be 5.5.
4. That is correct. Did you get that? No.
Otherwise, you'll get 33 over 6, and you can simplify that down from there. So 11 halves or 5.5. There you go. See?
Did you really draw the ohm sign and draw the
Huh?
Did you draw the ohm sign and then
Yeah. Totally did. Yeah, because current is amps, not ohms. I just got in the habit of doing ohms. All right. I want you guys to look at the practice you picked up today. I want you guys to start with 1 and 2. So, number 1, 4 resistors, 1, 2, 5, and 10 are in series. If the circuit is connected to a 5-volt source, find the equivalent resistance and the equivalent current. Number 2, 4 resistors are in parallel, connected to a 5-volt source. Find the equivalent resistance and the equivalent current. So go ahead and do 1 and 2. Solve those. If you need to borrow a calculator, come borrow a calculator.
Sam, can you give me a...
Mr. Damon needs a calculator.
You can help him out.
I guess.
Sam. Thank you so much, Sam.
Mr. B, can you come here and check mine? I already have mine done because I'm so awesome. Ryan Gosling. It's the Ryan Gosling.
It's the right.
Yeah, me and Eric. Break it. Do it right now.
Yeah, you were just silly.
I get so
1,
silly.
2, 5, 6, 10.
Oh, I forgot. Oh, Mark.
Especially these first
What are we
ones.
calling
These first
it?
ones are just super.
I don't think any.
Distance or
One and number 3 is a little trickier.
Yeah, actually, my name's Brian.
You look at it for 10 seconds.
That's why I do an AP Calc.
10 seconds.
I'll look
is
at
too
something,
much.
and I'm like,
You get an AP Calc, you look at it for a second, and then you're like, nope, too much.
No, yeah, let me finish mine and I'll be